The cube root functions, if you guys remember, kind of look like an S shape like this. And the arrows are pointing to the sides, not top and bottom. The top and bottom ones are like they're pointing to the top and to the bottom. Those are called the cubic functions. Like you're taking x to the third power. But the cube root is the ones with the radical sign. They point to the sides, okay? So that's what we're going to learn how to graph today. So for prior knowledge, we're supposed to describe the transformations. The keyword here is describe, like in words. What do A, H, and K tell you to do? So first you guys have to figure out the A, the H, and the K. And if you remember, it's G of X equals A in the front times, this time's a cube root, so it has a little 3 there, times X minus H plus K. So you guys have to work together. I'll give you like about a minute or so, talk about what's A, H, and K, and then what do each of the 3 values tell you to do to the graph. The recording. All right, so again, we need to know what are A, H, and K in order to transform our graph, but it's going to be the same as we did with the square root functions. So we're going to be transforming the cube root function. So the cube root function is f of x equals the cube root of x. This is the parent cube root function. So in the red box right there, you guys have it on your paper. It says, recall that the domain of this function, so the x values, there's no restrictions, right? So I can have any x value between negative infinity and positive infinity. So that's called the set of all real numbers. Therefore, the x value of h is placed in the middle of the table. So whatever the h value is, in this case, my h value is 0. So then I put 0 in the middle of the table. And then it says the other x values in the table have been chosen because they are perfect cubes in the domain of the function. Because I have this cube root of x, I need perfect cubes. So that when I take the cube root, I get a whole number, right? So what this is saying, though, is if I plug in all of these x's into the function, like the first example, cube root of negative 8, that means what number multiplied by itself 3 times gets you negative 8? That would give me a negative 2, right? Negative 2 times negative 2 will be positive 4. And then 4 times negative 2 would give me a negative 8. So the number multiplied by itself 3 times is negative 2. And then if we do the cube root of negative 1, one number multiplied by itself 3 times gives you negative 1. That would be negative 1, right? 3 negatives is going to give you a negative. And then 1 times 1 times 1 is 1. And then the cube root of 0. What number multiplied by itself 3 times gives you 0? 0. And then the cube root of 1. What number multiplied by itself 3 times gives you 1? And then the cube root of 8 would be 2. Because 2 times 2 is 4. 4 times 2 gives you 8. So multiplying by 2 3 times gets you to 8. So now I have the 5 points right here. I got negative 8, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 8, 2. You guys need to memorize the 5 points. We had the other 4 for square roots. Now we have 5 new ones for the cube root functions. On the test, we will not give you guys the 5 points or the other 4. So you guys need to know which points to use for each function, okay? And then we need to graph them. You guys have the axes on there. I don't, so let me draw it really quick. But you guys can start graphing it. go graph -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2 on your paper. Alright, so -8, -2, you go left 8, down 2. -1, -1, you go left 1, down 1. 0, 0 is at the origin, 1, 1 is right 1, up 1. And 8, 2, you go to the right 8 and up 2. And then when you guys connect these, they have to be pointing to the sides, okay? Not pointing up or down, they point to the sides. So starting on the left side, curving this way, and you end up on the right side. And I'm going to label that as f of x. That's my parent function, f of x there. Okay, so today we're going to learn how to transform that parent function. We're going to be like stretching it. We're going to compress it. We're going to shift it to the sides, shift it up and down. We're going to do a whole bunch of stuff to this function here, okay? All right, so the concept slide here, continuing, it says, in order to graph a cube root function, you guys have to know your 5 key points, -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. And then the first thing you want to do is find A, H, and K and determine what each of the values do to the graph. Then you're going to use your 5 points and you're going to use transformations like we did it, stretch it, flip it, go to the left, go to the right, up or down. Or I will show you guys how to do it mathematically today because I noticed in first period a lot of students are like they are still struggling with like visually interpreting what to do to the graph. So I'm going to show you guys mathematically how to do it, okay? And then once you have your 5 points, you're going to graph them with a smooth curve to represent the function. And then don't forget to always label the graph. Label the function. Usually it's called g of x in the example, so don't forget to put g of x inside the graph. Okay? All right, so let's look at our first example. Can I have you guys please copy this first example here? G of x equals a 1/2 times the cube root of x plus 2 minus 3. All right, so we need to first find A, H, and K. Go ahead and righties tell your partner what are A, H, and K here. All right, Nick, can you tell me A, H, and K?
A is 1/2, H is -2, and K is -3.
Awesome, thank you. All right, so now that I have my my A, H, and K, I need to remember what the key points are. So key points, I like to write them down every single time just because if you keep writing it, it's easier for you to remember them, okay? So -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. Those are my 5 key points. I'm going to transform them depending on what A, H, and K tell you. So A, first of all, do I have an x-axis reflection? Is my A negative? No, so I don't have a reflection. I have a 1/2, so is that a vertical stretch or a compression? Compression, right? It's between 0 and 1, so we compress it. So, remember what we did? We actually take the distance and then we cut it in half, right? So we cut the distance from the x-axis in half. And then if it was negative, then we would flip it across the x-axis. But it's not in this case. So then you go to your translations. The translations are your h's and your k's. So h is negative. So which direction do I go? Left or right? Left. 2 units. Thank you. And then my k value is negative. So what does that mean? Down 3 units. Okay. So to graph this here, I'm going to go to -8, -2, which is right here, -8, -2. How many units away am I from the x-axis? 2. So what's half of 2? 1. And then from 1, I'm going to go to the left 2 times, so 1, 2. And then down 1, 2, 3. So I end up at -10, -4. Okay, so cut it in half and then go left 2, down 3. So let's go to the next corner point is -1, -1 right here. What's the distance to the x-axis? 1, and half of 1 gets you the 0.5. So then from the 0.5, I go left 2, so 1, 2, and then down 1, 2, 3. We end up at -3, -3.5. -3, -3.5. My next coordinate point is 0, 0. The distance from the x-axis is 0. So 0 divided by 2 is still 0. So all I do is the translation from the origin. So we're going to go left 2 and then down 1, 2, 3. And I end up at -2, 3. -2, -3, sorry. -2, -3. Okay, then from 1, 1, +1, +1, what's the distance from the x-axis here? 1. So if I cut 1 in half, gets me to 0.5. And then from the 0.5, we go left 2, then down 1, 2, 3. We end up at -1, -2.5. -1, -2.5. Then for my last coordinate point, I'm at 8, 2 right here. 8, 2. The distance to the x-axis is 2. Half of 2 gets me to 1. And then from the 1, I go to the left 2 and then down 1, 2, 3. And we end up at 6, -2. So now I just have to connect the dots together and then arrows pointing to the sides, starting at the left side over here. We're going to connect the points and then end up pointing towards the right. And then we need to label the function g of x. Okay, so if you look at this one, it's like very like smushed together, and it's like a skinny version of it. And it's pointing to the sides. Okay, that was a compression, vertical compression. We cut it in half. So now let's look at a stretch. Our next example is a stretch. Well, actually, my bad. This one's a practice, so you guys can go ahead and practice this one. This one actually doesn't have a stretch or compression. A value, what's the A value in this example? Well, I'll let you copy it down first. We got g of x equals the cube root of x minus 1 plus 3. All right, so what are A, H, and K? Go ahead and lefty side runner, what are A, H, and K? You guys should be sharing. I'm hearing like one person. All right, Simran, can you tell me what are A, H, and K?
A would be 1.
Mm-hmm.
H is positive 1. No, yeah.
Mm-hmm.
And K is positive.
Positive 3. Okay, good. So this A is 1. I don't have a reflection, and it's equal to 1. So I don't have a stretch, and I don't have a compression. So this time, A doesn't do anything to the graph, okay? All you're going to do is a translation of right 1 up 3 in this example, okay? So take your 5 points. All you're doing is go to the right 1 time and then up 3 times. You guys go ahead and try this one. Okay, so again, here's the solution for you guys to check. A value is 1, so no stretch or compression. All you do is go to the right 1 time and then up 3. So from -8, -2, go right 1, up 1, 2, 3, and so forth. You do it to all 5 points, and you should have ended up up there. And don't forget to label the function g of x. Okay? All right. Let's go ahead now and look at a stretch. So go ahead and copy this example. G of x equals -2 times the cube root of x minus 3 plus 5. -2 times the cube root of x minus 3 plus 5. Okay. Go ahead and share with your partner. Let's see, whoever has like the biggest hand, I guess, can share first. Whoever has the biggest hand can share first. What are A, H, and K? Are you guys like asleep or something? I'm asking you guys to talk, and you guys are like so quiet today. Let's see, Jackie, what are A, H, and K? Okay, good, thank you. All right, so my key points this time, well, they're always the same. But my key points, I'm going to write them like sideways this time because I'm also going to show you guys how to do it mathematically, but I'll do it after. So my key points are -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. My A value is negative this time, so remember, what does the negative tell you to do to the graph? A reflection. And then the 2, is that 2 a stretch or is it a compression? A stretch because it's bigger than 1, right? So first, you want to stretch it by 2. So stretching by 2 basically means double the distance by 2, okay? So double the distance from x-axis. And then you want to do the reflection. So step 2 is then do the x-axis reflection. And then the third thing you want to do is the translations. So the translations, this time h is positive, so what does that mean? What direction do we move? Right? 3 times, thank you. And k is positive, so what does that mean? Up 5 times. Okay? So take your coordinate points. We're going to double the distance. After you double it, you reflect it across the x-axis, and then you go left 3, up 5. So if I look at -8, -2 right here, what's the distance from the x-axis? How many units? 2. So I'm going to double the distance down to -4. So now I'm 4 units away from the x-axis. At the -4, I then have to flip it over to the other side of the x-axis. So where do I move from -4? -4, I flip it to +4. And then from +4, I go to the right 3 times and up 5. So right 3 goes 1, 2, 3. And then up 1, 2, 3, 4, 5. You guys should have ended up at -5, +9. Double check, did you end up at the same spot? -5, +9? Okay. All right, my next one is -1, -1, which is right here. What's the distance from the x-axis? How many units? 1. So if I double 1, it would give me to the -2. And then I have to flip it over to +2. And then go to the right 1, 2, 3. And up 1, 2, 3, 4, 5. So we end up at 2, 7. 2, 7 right there. Okay? All right, 0, 0. Whenever you're at the origin, the A basically cancels out. So basically all you're doing is a translation from the origin. Okay? Because the distance, if I double the distance, it's still 0. And then if I flip it, it's on the x-axis, so it stays there. So we're just going to go to the right 3 and up 5. So 1, 2, 3, up 1, 2, 3, 4, 5. We end up at 3, 5. All right, you guys go ahead and do the last 2 points and see where you end up at. Go ahead and translate 1, 1 and 8, 2 and see where you end up at. I will be calling people for the coordinate points, so make sure you guys are doing it. All right, go ahead and righties, if you're sitting on the right side, share with your partner the coordinate for 1, 1, where did you end up at? And then lefties, tell your partner for 8, 2, where do you end up at? All right, so for my coordinate 1, 1, where do you end up at, Carlos? For 1, 1, when you move it, where do you end up at? You need to put the phone away. You need to pay attention. Hannah's not here. Jennifer's not here. Ashley, can you tell me where did you end up at? 4-3. So 4-3 right here. Did you guys all end up there? 4-3. That looks about right on the. Compared to the center point, that does look right there. Okay, for last one. 8-2. Where did you end up at, Isabella? For 8-2. No. Deep Drop, where did you end up at? 11-1. Thank you. All right, did you guys all end up there? 11-1. Okay. So then you're gonna take the points and you're just gonna connect them, and remember you're pointing to the sides, not to the top and bottom. So starting at the left side, you're gonna curve towards that point right there. You kind of curve up and then curve down and end up pointing to the left side over there. And then this is the function g of x. Okay? I wanted to show you guys how to do it mathematically because just in case if you're struggling with the whole like doubling the distance, flipping it, shifting it, there's a way to do it mathematically. So I'm going to show you how to do it mathematically. You can add it to your notes. It looks like you should have enough space to do it on your notes. So the other way to do it is using this mathematically. We're going to take our x value and we're going to be adding h to them. Okay? And then we're going to, let me zoom in so you guys can see what I'm doing. Then you're going to take the y value. You're going to multiply by a. So you're doing a times y. And then you add a k. And then that's going to give us our new coordinate points, x and g of x. Okay? So mathematically, this is how you're going to do it. Okay? You're going to take your 5 points, 5 key points. You're going to put them under the x and the y. So my 5 key points are -8, -2. But I'm going to put the y's in parentheses because I have to multiply by a. Then I get -1, -1, 0, 0, 1, 1, and 8, 2. Okay? Those are the 5 key points. You put them under the x and the y's. Then we're going to add h, which I'm trying to find h. H was 3. So it's a positive 3, so I'm going to go ahead and add 3 to all of my x's. And then for a, it's a -2, so I multiply all of these by -2. All of my y's by -2. And then we add k, which k is 5, so I'm really adding 5. If your h and k values are ever negative, you're basically subtracting instead of adding, but this is the same concept. Okay? Now I just do my calculations. So what is -8 plus 3? -5. So I'll put -5 here. -1 plus 3, or 3 minus 1,
2.
gives you 2. 0 plus 3, 1 plus 3,
4.
and 8 plus 3
11.
is 11. Thank you. For my y's now, that's -2 times -2 will give us +4, and 4 plus 5 gives you 9. -2 times -1 will be a +2, and 2 plus 5 gives you 7. -2 times 0 is 0, and then 0 plus 5 is 5. Negative 2 times 1 is negative 2. Negative 2 plus 5 gives you 3. And then negative 2 times 2 does negative 4 plus 5 gives you positive 1. So those are the coordinate points. Notice I got negative 5, positive 9, which is here negative 5, positive 9. I have positive 2, positive 7, positive 3, positive 5, positive 4, positive 3, and 11, 1. So these are the coordinate points for this graph here. So if this is confusing to you guys, doing it with the A's, H's, and K's with the reflections, doubling the distance, moving it left, right, up, down. If this is confusing to you guys, you can do it mathematically this way. It is more time consuming because you have to do all the tables and the calculations. But if you can do it in your head without drawing the table, then that's the way to do it also. Okay? I just wanted to show you guys mathematically because I know everybody's brains is different. Some people are visual learners. Some people are like concept-based, mathematical-based. So however your brain is wired to do it, if this makes more sense to you to do it that way, or if you would like to do it mathematically, I just wanted to show you guys both ways, just in case, however you prefer. Okay?